Hi class. In this video we'll be talking about first order linear equations. And by linear here I mean just generic linear, not constant coefficients or anything. So I'm going to start with exercise number 2 in the book. It's x squared y prime plus xy equals 1. And the idea for these is to first get it in standard form, which means to get a coefficient of 1 on y prime. So we do that by just dividing by x squared. And note here that since we've divided by x, if x is 0, we're going to have a problem. So effectively what this procedure does is it says if we've ever divided by 0, we can't include that in the domain of our solutions. So whatever solution that we get here, it's only going to be good for either positive x or negative x, but nothing that includes the origin. Okay, so once we have it in standard form, we continue, and the next step is to find the integrating factor mu. The integrating factor is e to the integral of whatever is multiplying y, and you keep the sign. So if it was minus 1 over x, we would keep minus 1 over x. In our case, we get log x. Technically, we would get log of absolute value of x, but because of what I said earlier, that the solution is only going to make sense on either positive or negative, let's just imagine that x is positive. E to the log x is just x. So the idea now is to multiply everything through by the integrating factor. I multiply my standard form, and then I'm going to get x y prime plus y equals 1 over x. Now, the reason that we do this is that our left-hand side, the side with the y primes on it, is the product rule. This is the derivative of the quantity xy. So we have the derivative of x times y equals 1 over x. Now to finish this problem, we integrate both sides with respect to x. On the left-hand side, of course, we just get xy. In general, whatever mu was, we'll just get mu times y. And then I have work to do on the right-hand side. It's not a whole heck of a lot of work, but it's still there. Okay. So note here I use the same feature. If x is just always going to be positive from here, it's going to be positive from here, so you can forget about the absolute value. And so what we get is that y equals log x over x plus c over x, where x is greater than 2. Now, there is one comment to make that I sort of left out. Why didn't I put plus c here? Well, if I did put plus c here, using my exponent rules, I would just get another constant out in front of the exponential. Multiplying everything through by that constant, well, that's fine, except I could just divide it back out. So you may as well pretend that that constant out front of the exponential is just 1. In any event, this is what we get as our solution. So the steps are put it in standard form, find the integrating factor, multiply by the integrating factor, recognize the product rule, and integrate both sides. And then notice we can solve for y easily. Okay. Let's see another example. This one is number 4. We have y prime plus secant x times y equals cosine x. This one happens to already be in standard form, so we can jump right to finding the integrating factor mu, which is e to the integral of secant x dx. And once again here, we have e to the log of secant x plus tangent x. Again, we could put plus c, but we're going to pretend that ultimately the constant out front of the exponential is 1. And now we say, okay, well, we have this absolute value business problem again. Luckily, secant and tangent are bad at the same places, this being 1 over cosine, this being sine over cosine. And so we just pick a region which they have the same sign so that we don't have to worry about crossing that 0. And we're just going to ultimately simplify this to secant x plus tangent x. And forget about the absolute value for now. Okay, well, when I multiply through by that, I get secant x plus tangent x, y prime, plus secant squared x, plus secant x tangent x, y, equals, now when I multiply by cosine, I get 1 plus sine x. Now it might be hard to see, but the left-hand side is still a product rule. In this case, it's secant x plus tangent x times y. It's easiest to check going backward. To do the product rule, it would be this term times the derivative of that, which is right there, plus the derivative of this one, which is secant tangent plus secant squared. That's right there, times y. So now we just integrate both sides with respect to x, and we get secant x plus tangent x times y equals the integral of 1 plus sine x dx, which is just x, and then minus cosine x plus c. So we get y is x minus cosine x plus c over secant x plus tangent x. And that's it. Again, we have the same caveat from before. We have to make sure that these are both positive or something. On a region where both of these are, say, positive, we're in good shape.